Mm. Oh. Oh. Mhm. Okay. Into mhm. Let's see. Hello, friends. Hello, enemies. Or there might be some friends that are thinking about becoming my enemies. Mhm. I don't know how. It's possible. Yeah, I have to think about myself. Do I have some friends that I'm thinking of becoming enemies with them? That's an interesting question. Maybe some friend I imagine did me wrong or not paying attention to me or something. hmm Something that I need to think about. Uh, let's see. Well, let's see. Turn on the turn on the. Here we go. Turn on the microphone. No, the video. Okay, so yes, I'm walking the dog Naya. It's September 11th. The dog's peeing. Okay. Mhm. So, you know, I was, sometimes I think about the golden rule, and something triggered me into thinking about it. And so I Googled, actually, now I Gemini AI Pro it. Gem, Gemini AI Pro'd it. I I did that. Like, so basically I'm asking, so what's the Christian golden rule? How does it go? So I got the answer. Let's see if I can bring it up. I'm going to share screen. I think so. Well, coding up here on top. Wow, so, okay. Entire screen. Okay, so I got it working. Um, Go over here. So here's the original. What is the Christian golden rule? So I copied and pasted it over to my notebook. Uh-huh. Oh man, I got too many things open. Let's see. Do 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 do. Just. Mhm. Oh no, I closed the one I shouldn't have. Maybe. Mhm. September 11th. That's correct. That's right. That's the one that I was looking at. Let's see. There we go. So if I go over here, down to here. And Christian golden rule. So there's some interesting things to think about here. So the Christian golden rule is a central ethical principle that summarizes the Christian's duty to their neighbor. It is found on the New Testament in the book of Matthew, chapter 7, verse 12. Oh, wow. I haven't gotten there yet. I'm still stuck on chapter 5 in the Sermon on the Mount. Maybe chapter 6, too. I kind of stalled on it. Like a lot of things get stalled. As stated by Jesus during his Sermon on the Mount, the rule is so in everything, do to others what you would have them do to you, for this sums up the law and the prophets. Mm-hmm. Mm-hmm. So, in everything, do to others what you would have them do to you, for that this sums up the law and the prophets. Mm-hmm. Wow, that's amazing. Hmm. The law. Hmm. I could interpret, or I could play with the idea that the law is the Dharma. Dharma. The Vedic, Hindu, Buddhist, Jain kind of word. So this sums up the Dharma. In other words, the religion is summed up that way, and the prophets are kind of like teachers, the Sangha. Mm-hmm. Mm-hmm. Dharma. And so the practice, the karma yoga, is to do to others what you would have them do to you. Let's see. Mm-hmm. I'll go over to. Mm, mm, mm. It's considered the the what's the implication of the application. Mm-hmm. The application of such rule. Of such rule. Sounds sounds correct. Yeah. Let's consider let's consider Oh, well, we like. Wow. Hmm. Oh, let's see. Hello.
Hello, hello.
Abhishek Shukla, welcome to Wake Up
Hello, hello. How are
Daily.
you? Hello.
How are you, Abhishek Shukla?
How are
Well,
you? Wake up and think clearly, family. I hope
welcome.
you are all doing well.
Thank you. Thank you. Thank
I
you for
am
joining.
I am preparing a prototype for my hackathon.
You are preparing a prototype for your hackathon.
Tomorrow is the presentation in my college of hackathon.
Tomorrow is your what in your college for the hackathon?
Yeah,
For the what? For the for the
presentation.
rehearsal? No. The present
Yeah,
to see if they let you join the hackathon or like an
yeah.
application.
Look it.
Oh no.
Look this.
Look here. Welcome back, student. It says computer science. It says current GPA 3.8.
This is this
Is
is
that
created by me.
is that 3.8 out of 4.0?
This is created by me. This software.
Oh, this software. It has welcome back, student overview. And what is the purpose of the software?
For maintaining the student record in college and
Is-
schools,
And,
for
and
preparing the timetable of college uh, according to the subject, students, number of student and teachers.
students, number of students, teachers, courses,
Yeah,
grades. Mhm. Wow, it's so complicated. How do you do it? Is
by
you need
using
database,
by using AI database and machine learning and some APIs.
Masila Ling?
Yeah,
What is that?
you don't know about machine learning?
Masinani? No, Masinani. How do you spell?
Machine learning.
Oh, machine learning. Oh,
Yeah, machine learning is a field of artificial intelligence where computer system learns from data to perform tasks and improve over time without being explicitly programmed.
wow. The machine will learn. It will learn and get better and
Yeah, today is Thursday. Why should you start, wake up and think clearly?
yes, today I hmm, I w- I decided to start it and investigate. Let's see. I was going to read a book into it, and then I decided to
But
investigate.
I saw a previous record of wake up and think clearly. There is no new viewers in our channel.
There is no. reviews or no
Viewer,
active
viewer, viewer.
river river river. What is that?
No one watching our videos.
No one watching our videos. Oh no, we have
Maybe I
to
have an idea. Maybe I will promote our wake up, our channel wake up and think clearly.
with yes, we could do that. Oh
I will put ad in Facebook, Google, and YouTube.
wow, thank you. And maybe wake up and think clearly needs a new logo like
You want
W.
a new logo for your channel?
Yes, something that looks like handwritten, like the letter lowercase letter WUTC. Wake up, think clearly. Like the little letters.
WUTC.
Yes,
Okay,
not
I will create for you.
like if I wrote it by hand. Hmm. Yes, and maybe red color or purple. Mhm.
Okay, I will create it tomorrow.
and then, and
When you
then,
go to office,
and then I will find all the videos where we play Vinci, and I'll put them in the beginning of the channel. Oh, I will.
okay.
But
Thank
I
you.
already, I already have a playlist of where we play Vinci. Oh, but I found one from wow, 4.5 years
Okay,
ago when we
now
first.
I'm going to prepare a prototype. Bye.
Bye.
Take care.
Thank you. You too.
Bye. Bye, YouTube family. Take care.
Take care.
Do subscribe our channel. Wake up and think clearly, and like also the video.
Yeah. Thank you very much. Good luck in the hackathon.
Thank you. Hiro sir is the best person in the world,
Oh no, Abhishek is the best.
and he is the co-founder of Avinova.
Wow, Abhi Nova. Hmm. Innovation in
Okay,
technology.
bye.
Okay, bye. Bye.
Bye bye.
I- I'm going to read
Take
from a
care.
book.
Take care, Naya.
I'm going to read a book.
Okay.
Oh. Wow. Oh, where was I? But first, before I read that book, I'm going to go back to Gemini. Okay. Wow. So I asked Gemini, do to others what you would have them do to you. Sounds correct. Now let's consider the possible implications of the application of such rule or practice of moral discipline. Consider the possible cases where what I like to listen to in music, and I have control of choice of music, like a DJ or host who has access to a music service like Spotify. It's connected to the sound system, like a closed space like a typical family living room with an entertainment center. And I choose to hear what I like to hear, assuming they might like it too. They could be family, like mother, brothers, and sisters, spanning a decade or two amongst the siblings. And the mother being 2 to 4 decades older than anyone else. Plus, you might have guests like wives or husbands of the siblings, and perhaps few children. There's a high degree of chance that some will rather not hear what you like to hear, so there will be some complaints. So I suppose then I have to put myself in their shoes and think, well, maybe songs I don't. So I should try to get songs they want to hear. There was an initial application of the golden rule, selfish, and then there might be protests from the crowd. So we'd have to think about what they would like to hear. So perhaps asking for requests to the audience. Then there might be shouts of play this or that. So you perfectly illustrated one of the most important nuances in applying the golden rule. Your scenario with the DJ highlights the difference between applying the rule superficially versus applying it deeper. Its deeper empathetic principle is break down your excellent analysis. The projection problem. Your initial application of the rule is a common and understandable one. It goes like this. What do I want? I want to hear my favorite music. Apply the rule. Therefore, I will do for others what I want. I will play them my favorite music. This is an act of malice. It is a projection of your own specific tastes unto others. Wow. You are assuming your preferences are universal. As you correctly pointed out, in a diverse group with different ages and backgrounds, this is almost guaranteed to fail. It treats the golden rule as a simple command to share your personal likes and dislikes rather than a deeper call to empathy. The empathetic solution. When the complaints come in, you are forced to reevaluate. This is where the true meaning of the rule kicks in. The thought process shifts from projection to genuine empathy. What is the principle I would want? If I were a guest at a party, I wouldn't necessarily want the DJ to play my exact favorite song. Instead, I would want the DJ to be considerate, to care about the enjoyment of the whole group, and to create a pleasant atmosphere for everyone. Apply the principle, therefore, I will do for others what I want in principle. I will be a considerate DJ who tries to create a good experience for everyone. This leads directly to your proposed solution, asking for requests. By doing this, you are no longer just projecting your own tastes. You're actively trying to understand and cater to the desires of others, which is the considerate behavior you would want from a host. The platinum rule. Your conclusion actually stumbles upon a famous evolution of the golden rule, often called the platinum rule. Treat others the way they want to be treated. Oh, wow. This is seen as a more advanced and nuanced version because it requires you to move beyond your own perspective. It demands communication, observation, and empathy to understand what another person truly desires, rather than just assuming they want what you want. In your DJ scenario, you instinctively moved from the golden rule's simple interpretation to the practice of the platinum rule. You realize that true consideration means understanding what others in the room actually want to hear, not what you'd want them to hear. Hmm. Let's see. Let me copy. See if I can copy this one. Like this. Copy. Then I go to this one to my notes. To the bottom was it. There you go. There. Mhm. But I made some errors. Hmm. Let's see if I can find them. So this is considered a possible case where consider the possible case. This is where I like to listen and control the music. I can figure out, and I choose to hear what I like to hear. Assuming they might like it too. They could be family, other brothers and sisters spending two amongst the siblings. Oops. And the mother being 2 to 4 decades older than anyone else. Plus, you might have guests, like the wives or husbands of the siblings, and perhaps a few children of their families. There is a high degree of chance that some will rather not hear what you like to hear. So there will be some complaints. So I suppose then, I have to put myself. So I suppose then in their shoes and think, well, maybe there are songs I don't want to hear. So I should try to get the songs they want to hear. And then there might be a protest from so I, as a DJ, would have to think about what they would like to hear. So perhaps I could solve this by asking for requests. Then there might be shouts of play this or that. Mm-hmm. Hello. Okay. Mm-hmm. Mm. Okay, yes, I didn't know about that. Mm. Mm. Mm-hmm. Mm. 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 Uh-huh. Uh-huh. Yeah, there's a fella. Wow, interesting. Okay, so that's something I'd like to think about more. Okay, so now let's go to. Oh, I know what I could do. I'll take a picture. Mhm. Uh, ah, Picture. Then let's see. Uh-huh. Uh, ah, Mm, damn, damn, that's a lot of pages. Mm, I'm gonna stop here. So I got some pictures, and then I switch over to uh, let's see, let's see, let's see. Hmm. Can I start in this order? Yeah, I guess I should go like this. I go like this. Uh, uh, mm, 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 mhm, mhm. Yeah, this should have cut this one a little bit more. Uh-huh, uh-huh. I think I get it all. Maybe I should apply lighten. What's that? Or document? Yeah, document. Yeah. Except maybe this one. Oh, right. Okay. Oh, bench. I don't know. Okay, so how do I? Okay, so I'm gonna put beyond infinity. So, beyond infinity. Hmm. Okay, I get it all. And um, what can I- so I can go to my gallery and go to this lens. Would it be there? It's in here. Oh, no, it's not in there. Why is it not in there? It's in. Oh, maybe it's not up yet. Shit. Hmm. I'm gonna go back in here and just go like that. Let's try that. Okay. Okay, so I'm studying Beyond Infinity. That's by Eugenia Chang. Short listed for Royal Society Book Prize, an expedition to the outer limits of the mathematical universe. Clear, clever, and friendly. So let's see if I can capture infinity. The S of infinity, because it seems to slip away from me. So infinity slips away from us again. Is a typical refrain of small children on long journeys. They experience time differently. So 10 minutes can already seem like an awfully long journey, which can be a bit trying for the adults if the journey is going to take several hours. Yeah. Are we there yet? Is the typical refrain of small children in long journeys? They experience time differently, so 10 minutes can already seem like an awful long journey, which can be a bit trying for the adults if the journey is going to take several hours. Wow. So I recently swam back along the coast of Lake Michigan. Wow. From a walk up a sand dune. Isn't it dangerous? The coastline curved out of my line of sight. So I repeatedly thought I must have nearly made it back to our beach of departure. But when I arrived, it just curved round to reveal more beach. I ended up singing songs in my head to try and get a sense of how long I had been swimming. So mathematics can sometimes seem like a process of never getting anywhere. Because every time you work out something new, every time, every time, every time you work out something new, it just reveals all the other things you don't know. And it's hard to keep track of where you come from because we're once we understand something, can be hard to remember how difficult it used to be. Wow. I often feel like I'm making no progress in math because everything I already know seems easy, and everything I haven't done yet is difficult. Otherwise, I would have already have done it. Otherwise, I'd already have done it. We're going to keep going with our journey through the numbers. Now that we know we haven't yet arrived at infinity with the natural numbers. Mhm. Arriving at infinity with the natural numbers. So we couldn't arrive infinity with rational numbers, natural numbers. Anyway, children accomplish learning how to count, and then almost immediately they have to learn how to uncount. That is, subtract. Okay, that's a good way to look at it. As children learn more and more about numbers, they gradually learn about more and more different types of numbers. Somewhat following the historical, oops, wrong way, development of numbers, but with thousands of years of gradual mathematical discovery compressed into a few years of school. Wow. Such is the power of education. Wow. However, we need to cross examine these types of numbers more closely in order to see for sure whether infinity is one or not. Like many things, it is a level of understanding you don't need until you start asking difficult questions. What is infinity? Is one of those difficult questions. It can seem futile, dry, or pedantic to spend so long thinking about definitions of things, but I prefer to think of it as revealing. It reveals how the ideas work. If I eat some delicious food in a restaurant, I immediately want to know how it was made, perhaps get the recipe. If I am taken on a spectacular journey, I'd like to see on the map where we went. So investigating what all these numbers really are is the same kind of thing. We're going to see that each new type of number is built from the types you already had, together with a desire for more subtlety, desire for more subtlety, or expressive power. Okay, so new numbers from old numbers. Okay, so we're gonna build upon old numbers. Looks like. So mathematicians love building things up from previous things, using a little extra work, as little extra work as possible. This sounds like laziness, but I like to think of it as a conservation of brain power. Our brains are finite. Our brain power is finite. And we should save it for the times we really need it. Oh, and our life is finite. Well, this life is. There is a joke about mathematicians that goes like this. You give a mathematician a saucepan and an egg and ask them to boil the egg. Uh-huh. They fill the pan with water and boil the egg. Now you give them a saucepan full of water and ask them to boil the egg. Wait a minute, what happened? Now you give us full of water and ask them to boil the egg. They tip the water out and say, I have reduced the problem to the previous one. What? That doesn't make sense. So building things up from previous things has other advantages besides saving brain power. It helps us see the relationships between different concepts. Helps us understand how things fit together. Imagine a baked Alaska recipe that didn't tell you the goal was to put together cake, ice cream, and meringue. It would be rather unclear if you didn't already know what a baked Alaska was. So we can gradually build up more and more complicated types of numbers, starting with the natural numbers. Mhm. They get progressively less and less natural until they're so unnatural that they get called things like irrational and imaginary. Mathematicians often like to name new concepts with words that come from ordinary life, give us an idea of the characteristics of the new concepts. If we give abstract concepts some character that we can relate to, it can help us feel comfortable with them. I think that there's something endearing about an imaginary number. In a prime ideal sounds a bit like a juicy cut of beef, but perhaps that's just me. And prime ideals have nothing to do with what I'm talking about here, apart from that they sound tasty. The next type of number that we build from the natural numbers is the integers. Okay. Wow, integers. Natural numbers, integers. Hmm. So this includes all the natural numbers and all the negative versions and zero. Oh, so natural numbers are the counting numbers. Hmm. I just realized that, right? Like the natural number 1, 2, 3, 4, 5, 6, 7, 8, so on. But then the integers are those and including zero and the natural numbers, but with a minus sign in front of them. Negative number. Okay, so wow. This comes from our desire to be able to subtract things. Mhm. And we are able to subtract beyond zero this way. So you might remember being frustrated when you were little and hadn't learned about negative numbers yet. Maybe you were frustrated by the fact that you could add any number together, at least in principle. But you were told you could only take away smaller numbers from bigger numbers. But then I was frustrated about practically everything when I was little. Well, mathematicians are frustrated by this too. In order to subtract anything from anything else, we need to have negative versions of the natural numbers. This gives us the integers, which include the positive natural numbers and the negative natural numbers and zero. Well, when I say positive and negative, that means I'm putting a plus sign in front of them, and then negative natural numbers. I'm putting a negative sign in front of them to make them the negative numbers. So the positives and negatives and the zero together make up the integers. Yay! Let's see. Well, mathematicians. So we need the integers are better than natural numbers in the sense that we can do more things with them. Yay! We can do more things with integers than with natural numbers. Yay! So if you're buying numbers, don't just buy the natural numbers, buy the integers. Well, if maybe they cost twice as much, well, maybe you can get discount and get them for only 30% more. Then that's a good deal because you can do so much more with integers than with just natural numbers. Because the integers include the natural numbers. Yay! Okay. Because you see, when you subtract, you may end up needing the integers when it goes below zero. Or is it to the left is zero? It depends on how you look at it. Subtraction is exactly what caused us problems with infinity in the last chapter. Oh, wow. There was a problem with infinity in the last chapter. When we discovered that subtracting infinity from both sides of an equation could not be valid. Oh, no. Subtracting infinity from both sides of the equation might not be valid. Mm. This is a big clue about what infinity can and can't be if we can decode it. Oh, wow. You mean to tell me that is it possible to have negative infinity? Wow. Mhm. Whoa. Mhm. Okay, so mathematically, we say every number has an additive and inverse. Every number has an additive inverse. This is a number that undoes the original number. We can say every number has an additive inverse. This is the number that undoes the original number. That is, takes us back to zero. Oh, the additive inverse of positive 1 is negative 1 because it takes us back to zero. Okay, does that work with infinity? We have positive infinity. We add negative infinity to it. Do we get zero? Mm, that's a question. Or do we get negative or zero infinity? Mm-hmm. Mm-hmm. Mm. Okay, let's go. How you get? Okay, okay. How do you get back from two back to zero? You add negative two. How do you get back to? How do you get from n back to zero? You add negative n. Okay. So demanding that every number has an additive inverse is like demanding that all your Lego people have helmets. If you're a spoiled child, then as soon as you make that demand, your parents will acquire Lego helmets for all your Lego people. Oh no, those kids are demanding. One of the fun things about mathematics, which is not publicized nearly widely enough, is that you don't have to be a spoiled child to get everything you demand. As soon as you demand additive inverse, As soon as you demand additive inverse for numbers, poof, you have additive inverse for all the numbers. This makes mathematical research great fun. You can have anything that you can think of. The only caveat is that you have to take all the logical consequences of your new toy as well. If you're a spoiled child and ask for a lion, your parents might give you a lion, but the lion might eat you. Mhm. If you're doing mathematical research, no, and you're doing mathematical research, and you're doing mathematical research, and you decide you really want zero to equal to one, that's perfectly fine. It's just that everything else will have to equal zero as well. So your world will collapse as if eaten by a hungry mathematical lion. Okay, now let's look at fractions. Wait a minute. Okay, wait, let's look at the bottom footnote. You could say, if you decide you want zero to equal two or any other number, that's fine. You just end up with a circular world called modular arithmetic. Deciding 0 is 12 is how we tell time. Wow, that's wild. Deciding 0 is 360 is how we measure angles around the compass. Wow, that's amazing. It's called modular arithmetic. Wow. Wait a minute. Hmm. Hmm. Okay. I'm not sure what happened here. Oh. Maybe infinity steps away from us again. There might be a page that I skipped. Anyway, fractions we have tried to get. Or maybe this one is next. Let's see. Mathematical line. Okay. I'll have to take a look at the book. I got the book in my bag. Let's go to page 43. 43. Oh, wow. There's some pages missing. Hmm. See? Let's see. Oh. Hmm. I'm missing that one. That one. Anyway, let's stop here and we'll it was not exactly in the sequence, and we didn't get through Hmm. So I read new numbers for old numbers. Hmm. Yeah, I read that, I think. What is this? I have to maybe edit it and rotate it. This. Then save it. So I read this. I read this. Okay. So two of them. Oh, so we didn't read this. That talks about integers. Uh, okay, let's look at that footnote at the top. Hmm. So mathematics often develops by mathematicians feeling frustrated about being unable to do something in the existing world. So they invent a new world in which they can do it. Wow. I like to think of us as invet, inveterate rule breakers. As soon as we're presented with a rule saying we're not allowed to do something, we want to see if we can make a world in which we can do it. This is very different from the popular conception of mathematics as a subject in which you have to follow whole loads of rules. Wow, we can be inveterate rule breakers in mathematics. And then we can apply it to physics. Wow, I'm going to become an inveterate rule breaker. Hmm. The first thing we demand in the world of integers is zero. If we didn't already have it in the natural numbers, oh, because we could have started the natural numbers with zero. Maybe that's a alternative natural set of natural numbers. Hmm. So zero is a special number which has the property that if you add it to any other number, nothing happens to that number. No matter what n is. Okay, now we demand that addition can be reversed or undone. Mm-hmm. This is like having a return policy when you buy something. It makes me nervous buying something if I can't change my mind and return it. Mm-hmm. That's right. Mm-hmm. It doesn't mean I always do change my mind and return things. It's just comforting to know that I can. Okay. And oftentimes we check on the return policy and say, oh, it can this be returned? Oh, yes. Okay, so I'll go ahead and buy it. I'm sure I'm not going to return it because I'm going to strive to like it. Because it makes me feel good to know that what I buy, I like, and I use. Eventually. Okay. So, how do you change your mind and return a number once you've added it? You subtract it. You use the subtraction operation. Another way to think of it is that you add a negative number to it. Okay. It's just like when you really Do return something in a shop or like on Amazon, and they give you a receipt with a negative total on it. And a negative total will be charged to your card, which in practice means that an amount is subtracted from your bill. Yay! From your transactions. What's it called in accounting terms? Refund or what is that? The deposit? No, not quite. But it works like one. Uh, Return? What did the banks call it? That's a good question. Anyway, mhm. It is important for us to understand subtraction a bit more. Wow. I don't know. What's this? I think maybe I need to take a look at this. Okay. It is important, going back to this one, it is important for us to understand subtraction a bit more because subtraction is exactly what caused us problems with infinity in the last chapter. Oh no! When we discovered that subtracting infinity from both sides of an equation could not be valid. Wow. Hmm. Why is that? This is a big clue about in what infinity can and can't be if we can decode it. Wow. Mathematically, we say every number has an additive inverse. Mhm. Sorry, we can't answer. This is the number that undoes the original number. That is, takes us back to zero. How do you get from 1 back to 0? You subtract it. You subtract 1 to put it in another way. You add -1. How do you get from 2 back to 0? You add -2. How do you get from n back to 0? You add -n. So demanding that every number has an additive inverse is like demanding that, oh yes, I read that. Mhm. What is this one? I'll have to edit it. I'll edit this one also. I may have already read this one. Huh? I go back to. Okay, anyway, as spoiled mathematicians, we can decide we want everything to have an additive inverse. And poof, just like that, everything gets an additive inverse. Don't get extra things, we just get those additive inverses. These are called the integers, and from the way we constructed them, we know they must consist of precisely the following things. So it must have 0, and it must include any natural number, and n -n, where n is any natural number. So written out, in a more obvious fashion, these are negative. Well, coming from the left side, going as far back as infinity, perhaps, is go negative this, negative that, in steps, whole number, whole amounts, all the way down to -4, then -3, then -2, then -1, and finally 0, and then it starts back up, counting upwards, 1, 2, 3, 4, etc. To infinity, you could say. So subtracting 4 is then technically defined as adding number -4. That sounds a bit convoluted, don't you think? But to mathematicians, it's actually less convoluted because you don't have to define a new operation, subtraction. You just use the same old operation, addition, to new numbers. Yay! That works pretty good in computer science too, because you can build a machine that only knows what to do. What its only function is to add numbers. And so if you throw in a negative number, you've actually subtracted. So therefore, you don't have to build a subtraction machine. Okay. Is infinity any of these new numbers? Oh, it doesn't look like it. But do we know for sure? It turns out that exactly the same proof by contradiction will work as for natural numbers. It's because integers must obey the same rule we use for natural numbers. Subtracting from both sides of an equation is valid. We know this isn't true of infinity, so infinity can't be an integer. Oh no, infinity is not an integer. Oh no, what do we do? So the hunt continues. Technically, what we're doing every time we demand a new type of structure is we're making something feely. No, something freely, not feely. When we made the natural numbers, we were demanding the ability to add one. The technical name for a mathematical world in which we can add a thing is a commutative monoid. Commutative monoid. The natural numbers are the free commutative monoids on one object, which means we make sure we can add anything we want. The free FREE part is that there are no extra what? Extra. Oh. There are no extra. Oh. So here's oh, where maybe we have to go here. Aha, there are no extra rules or constraints. Just addition and more addition as many times as we want. When we make the integers, we're demanding the ability to subtract, which is technically making the free commutative group, the free commutative group on one object. It's technically making the free commutative group on one object. A commutative group is the technical name for any mathematical world in which we can add and subtract things. Mm-hmm. 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 So we have tried to get infinity using whole numbers without success. So now we're looking at fractions. So we've tried to get infinity using whole numbers without success. So we need a different approach. Let's try fractions. What about instead of climbing up to infinity, dividing something up into infinity, into infinite pieces? You might remember being told at school, you can't divide by zero because it would be infinity. So perhaps we can get our hands on infinity by doing just that. Dividing something by zero. Perhaps we can define it as a fraction, 1 divided by 0. Unfortunately, that doesn't quite work either. Eventually, we'll see that there is some sense to it, but this sense is not in the form of an equation 1 over 0 is equals to infinity. It's much more subtle than that. Imagine dividing a cake up between 0 people. Hmm. How much cake will each person get? Question makes no sense because there aren't any people. You could say, the people get 10 cakes each. Hmm. Hmm. Okay, dividing the cake by one person, that one person gets the whole cake. Dividing the cake up by two persons, then each person gets half the cake. But let's go the other direction. Okay, we did one person. Let's do 0 persons. We get infinite amounts of cake. Wow, we can uh, we can create or generate. We can generate an infinite amount of cake that way and eat it too. Okay. Anyway, we could go on, but here's a good place to stop. Mm-hmm. Yeah, it's well, no, let's go a little bit further to get an idea of which way is going. So imagine dividing a cake up by 0 people. How much cake will each person get? That question makes no sense because there aren't any people. You say all the people get 10 cakes each because there aren't any people. So it's true that all of those 0 people get 10 cakes each, but all of those 0 people also get 20 cakes each. All of those 0 people get 40, 63 elephants each. Evidently, 1 divided by 0 is not exactly a sensible way to define infinity. In the case why we are told you can't divide by 0 if the answer isn't infinity in mathematics, why can't I is usually the wrong question to ask. The right question to ask is, why can I? The burden of proof means you have to justify everything you do logically. This is how all mathematics built up. Why can I? Mm-hmm. Mm-hmm. Hmm. Interesting. So now I must ask myself. Let's see if I can find it. Or if I go in here, total commander, I go to here, and then maybe go to here, and go to documents, and maybe Dharma docs, and then let's see, Vajrasattva practice. Yes, practice the mantra. Huh? So Om Vajrasattva Samayam Anupalaya Vajrasattva Tuino Patishta Drito Mebawa. Suto Sho me baba, Supo Sho me baba, Anurakto me baba, Sarvasidi me prayacha, Terma Kama Suchame, Chitan Chiyam Kuru Hum, ha 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 ho, Bhagavan, Sarvatata Vajrame Mucha, Vajri, Baba, Mahasamaya, Sattva, Ui. mm, Inspiradora, ok, 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 mm, mm, mm. Ven, ven, mm, mm. Om Vajrasattva Samayam Anupalaya Vajra Sattva Tunapatista Jido Me Bhava Suto Shyo Me Bhava Supo Shyo Me Bhava Anurakto Me Bhava Sarva Siddhi Me Prayacha Karma Sucha Me Chitam Sriya Guru Hum Ha 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 Ho Bhagavan Sarva Tathagata Vajramame Muncha Vajribhava Mahasamaya Sattva. See. Oh, let's see. Let's see. Let's look at all the. Mm-hmm. TD. Okay, so the green. Oh, the dark green is hmm, is E. E is Gigu. So look at the Gigus. So I see this first one. This one. Whoops. It's this one. That one, and that is D. I think D. Me Baba. Drito. It's like Drido Me Baba. I found Drido Me Baba. It's up there. Dri Di Di Drido. Dri. Hmm. Wow. This is a weird character. Oh, maybe it's over here. Drido Me Baba. Also, what is this last one? Before the Drido Me Baba. Hmm. Tishta. Okay, so this is Tishta. The one I'm looking at. Tishta. Tishta. And then this one, Drido Me Baba. Hmm. 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 Okay. Hmm. Mhm. 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 Okay. So yeah, that's Om Vajrasattva Samaya. Oh, that's Tibetan version. Samaya in the Sanskrit meaning version. I prefer, or some prefer, it be Samayam Anupalaya. Vajrasattva tweno patishta driddo me bhava. Supto shio me bhava. Supo shio me bhava. Anurakto me bhava. Sarva siddhi me prayacha. Sarva karma sucha me chitam shriyam guru. Ha 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 ha. Ho. Bhagavan Sarva Tathagata Vajramame Muncha Vajri Bhava Mahasamaya Sattva. Okay. Okay. So let's see. So yeah, the above is the Sanskrit, but in Tibetan characters. That's hmm, Unchin, headed characters. And then the bottom is how you pronounce it more or less, the Sanskrit. And I highlighted by certain colors, like the orange is for the O sound. So, for example, ha 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 ho. If you look for it, there's the ha 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 ho right there. The little bird flying above the last ho. That makes the ha go into ho mode. Ho mode. No, that means a naro. Naro, that symbol on top. I guess you could call it the critical mark if you like. I don't know if that's correct technically, but so I marked where all the O's would be. So there's a few of them. I can go through looking for other vowels, but I also wanted to look at the E. That's gigus, like sarvasidim, me prayatsa. So look at the green. Let's see if I could find it. So we could do it by counting how many greens there are to get to it. One, two, three, four. The dark greens, I think. So maybe I didn't do a good color coordination, but it's the dark greens, the fourth dark green. So I would count, let's see, one, two, mm, three, four. Yeah, I see it. It's right there. Sarva si dim me pra. Next line. Oh, yatsa. Sarva si dim me pra yatsa. So that's a good way to kind of finding your way around the text in Tibetan, which is representing the Sanskrit. So sometimes, like in this case over here, the the uh, the mark is backwards, and the word tri ma bawa. Mm. Dri 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 do me bawa. That would be Drido me bava. Yeah. Mhm. Yeah, that gigu is backwards. So maybe it's because it's a special Sanskrit Because some Sanskrit sounds, they managed to get it into Tibetan by changing what the character looks like. Doing a mirror image of it. Hmm. Let's see if I can see another one like it. Hmm. See if I can see another special Sanskrit character that's in Tibetan. I don't know them all very well. I've seen them, but I don't think there's any other than that one. Hmm. Okay, so let's go to the next one. Okay, so here's another way of chanting the Vajrasattva mantra. This is the way Enigma tradition. Let's see if I got what the Enigma tradition would be. Yeah, Om Vajrasattva Samaya Manupalaya Vajrasattva Tenopa Itra Drido Mebawa Suto Kayo Mebawa uh, Anurakto Mebawa. Sometimes they put this anu after supo. Supo kayo me bawa. Sarva siddhi me prayatsa. Sarva karma sutsa me chitam shriya or shreya kuruhung. Ha 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 ho. Bhagavan sarva sarva. Tatagata hridaya benzra mame munsa. Benzri bawa maha samaya satoa. So the Tibetans uh, don't have the va as in Victor sound, so they tend to make it sound like a wa. So that's why you have sarwa, and yeah, there's a lot of sarwas. There's one, two, three, at least. Yeah, but there's a lot of bawas that bawa in the Sanskrit, the was are actually bhava. Bhava. There's a bhava right there. Bhava. Which, hmm, interesting. Hmm, let's see if I can find it. There's a there's a bhava. Okay, it's a ba with a ha underneath it. Ba ba. Hmm. Oh, I know why it's like that. It's because the Tibetans don't have a third column for aspirated ba, which would be sound probably like ba, like Bhagavad Gita, Bhagavad Gita. Interesting. Well, I learned a lot, and it's a little bit of a practice of the Vajrasattva mantra. And I have let's see, I have um, let's see. So I have a lot of material for practicing Vajrasattva. Mm-hmm. See, I looked at that. The Way of Buddhahood. Is that my favorite one? Let's see. Let's open this up with Word. So I'm trying to study this book. Let's see if I can show you. Hmm. I could. So I'm trying to study this book right here. Hmm. That I've been wanting to. The Way to Buddhahood. by this master. Hmm. Yin Shun. I wouldn't say he's the teacher of Shun Yin, Shin, or that he influenced him, but this is kind of equivalent to a lam ram because they say here. Drawing upon the whole broad range of Buddhist thought, but especially upon the Madhyamaka tradition of Nagarjuna, Chandrakirti, and Tsongkhapa. Yin Shun has emphasized the rationalism and humanism of Buddhism while also bringing traditional Buddhist scholarship into invigorating dialogue with modern critical Buddhist studies. Master Yin Shun is the foremost living, well, now he's dead. So, The Way to Buddhahood, that's this book, his most widely read work, has been part of basic curriculum in many Chinese Buddhist schools and academies. Wow. So, he was born in 1906, Yin Shun. And he became a Buddhist monk in 1930. And he lived in Taiwan. And so maybe he was like a hmm, uh whoa, what happened? Oh, okay, go back to this. So he talks about other traditions of Chinese Buddhism, and he thinks highly of them. But he also talks about he also mentions introduction. He also mentions Madhyamaka. No, but he also mentions. Oh, where is it? Mhm, mhm, mhm. No, Dharmapala. Mhm. Aha. Preface. XI. When the Tathagata explained the Dharma, he always began by teaching the proper method, keeping the precepts, abandoning desire in order to be reborn in heaven. Concentration. Then, to those who might be able to renounce the world, he taught a world transcending doctrine because the emphasis of the Buddhist teachings is on transcending the world. Those who compiled the sutras always skipped over the Buddha's proper method. The ancient Abhidharma texts began with the five precepts, but later Abhidharma texts eliminated them. Even the Venerable Master Tsongkhapa could not avoid this tendency and used the teachings of the two vehicles of the foundation of his own. Thus in the Dharma common to the lower people, he held that mindfulness of death was an important entrance to the way. Actually, without being mindful of death, one can still practice the good deeds that will lead one to be reborn as a human or heavenly being. Although such a way for lower people follows the two vehicles in renunciation, it may not follow the compassionate way of the great vehicle. With regards to this, the master penetrated deeply into the Buddha vehicle. It exceptional revealed the real purpose of Tathagata's approach. Hmm. Hmm. Aha. So long ago, when I was in Hong Kong, I wanted to write a concise book on the path to Buddhahood. The book would draw on the discourses of Venerable Master Taishu and on Tsongkhapa's sequence of attaining enlightenment and integrating, oh, integrating partial views, sorry, from the treasury of the Dharma. It would interconnect all the Buddhist teachings and return them to the one vehicle. Hmm. So around 1954, he was able to write a few of those at a time with varying degree of profundity to teach the class at the Shandao Monastery in Taiwan. But they're very brief. And then a few years later, he revised and expanded those gathas, or I guess tata gata. What are gathas? I have to look it up. And so by a little later, he revised them again and began writing short commentaries. So eventually, he finally finished it a year later, and he submitted it for publishing. So he finally got it done by 1960. So it started in 1954, and it took him 6 years to get it done, little by little. So, and this is like his masterwork, and it's I think of it as like a Chinese lam rim. It has elements, or it was inspired by many different teachers, including Master Lama Je Tsongkhapa of the Tibetan Buddhist tradition. So there's a little bit of that in there. I'd like to go into that one. So let's see, go into that profoundly, and so yeah, I have some notes from his book here in Shuns. But before I want to get into it, I want to do some purification. So that's why I inserted the the mantra of Vajrasattva, Om Vajrasattva Sarvasiddhi Hum. So we could repeat that 100 times, going around a mala. But what is it we're purifying? Are we purifying our mind or our karma? Purifying karma would be erasing it, perhaps. So, so there's a website called studybuddhism.com, I believe. So from there, I looked up karma, and from that, I get the author Alexander Berzin, who studied under the teachers in the schooling of the Dalai Lama. Well, in Dharamsala, India, he got to study under Tibetan Buddhism under them. So he's saying that karma is not merely action. Karma is the compelling urge to act. If karma were actions themselves, then to stop building up further karma, all we would have to do is stop doing anything. That's absurd. This urge that will cause us to act is a mental factor. It's always accompanied by three other mental factors. The first is distinguishing, douches, usually translated as recognition. So that's where we distinguish an object from others. within a sense field. And this person, uh, for example, this person as opposed to that person, this object as opposed to that one. So we distinguish this from that. We need to distinguish the object at which our action will be directed. And the second is an intention, dunpa, that is, which is also like the aim. What do we intend to do? Intentional. We intend to hurt this person or help them. Then the third, there's an emotion that goes with it. It can be as a disturbing emotion like anger or a positive one like love. We want to hurt them because we are angry or help them because we feel love for them. So this urge that brings us to commit any action is the karma. So I'd like to look into Lorig, or the study of the mind. I think that's like part of the Abhidharma, but it is briefer and focuses on the definitions and the of the components and functions of the mind. Now, Alexander Bersing talks about the Vajrasattva mantra, and I put that in there. And then from another place, I grabbed the Sanskrit with English translation or interpretation meaning. So, for example, the light blue is the Sanskrit, and the yellow is kind of the Tibetan that might be a little bit different. How they uh, group syllables. So, for example, Vajrasattva Samayam Anupalaya. The Tibetans like to group the Samayam Anupalaya as Samaya Manupalaya. So it gives a different meaning. So yeah, the blue is the Sanskrit, and the brown is the Tibetan pronunciation. And I like to highlight the differences in yellow. Like supo hyo mebawa. I mean, yeah. Or suto hyo mebawa. They're similar. So instead of hyo, the Tibetans, for some reason, like to say kayu. So it's suto kayu mebawa, supo kayu mebawa. So I don't know how it got from hyo to kayu. I'd have to ask Tibetan scholars. Anurakto me bhava, sarva siddhi me prayatsa. In Tibetan, it's pratsa, prayatsa. It's interesting. Sarva karma sutsa me, shitam shriya kuruhum. In Tibetan, it's sitam shriyam. Instead of chitam, it's sitam. So it's a little bit of minor differences here and there. And go on. And then here I go on and talk about the book, The Way to Buddhahood. He's talking about the different schools of Chinese Buddhism. And I do a little bit of research on the different schools of Chinese Buddhism. And so this is a good introduction to the book, The Way to Buddhahood. So maybe I should start doing that. Yeah. So that's in here. I have another version of that one. Maybe it's not in here. Let's see what this looks like. Oh, okay. This has got the 100 syllable mantra in in Tibetanized Sanskrit, the way you pronounce it phonetically, and the explanation of the components, like samaya, is a sacred word of honor or a pledge or a promise that cannot be transgressed. Lead me along the path you took to enlightenment, Manupalaya. Interesting. Okay. And so that's that. Okay, let's go back to this. So, what's this one? I'm just going over things I haven't looked at. Okay, this one. Oh, this is a 7-line prayer to Guru Rinpoche. Supplications, other prayers, and the actual practice. Mm, 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 mm. And then here's the mantra. Yay! I printed that on, got it on the wall. And some final thoughts and concluding prayers. So this is like a sadhana that includes the Vajrasattva mantra. It's called Mirror of Vajrasattva's Enlightened Mind. Okay, so I looked at that. Mhm. Vajrasattva's mantra. 2. What's this look like? Okay, here's another version. And it's a Vajrasattva mantra. Okay, so it's got and still another. Oh, this is by Alexander Berzin. So this is Alexander Berzin's interpretation of it. Very good. Which is called Vajrasattva mantra 2. Essential practice. What's this one? Oh, okay. This is the oh this one's not. Yeah, it's not working. I don't like that one. Delete. Mm. Oh, maybe that's okay. Hmm. Hmm. Oh, is this open? Oh, here's the here's the sadhana that I should be following. You could follow that one most of the time. What is this? I don't know. Oh, that's a link. Oh, okay. I could. Hmm. Let's see if I can open it here. Yes. Copy, copy, and then go to Mm-hmm. Paste. No, you got pasted thing. Let's see what happens. Oh. Hmm. Oh. Wow. Oh, that's the same as the wonder. Oh. Maybe that's an earlier form. Hmm. Oh, look. 537. May 30th of last year. Okay. May 30th last year only? Okay. So I could rename this as link. Link to five. Yeah. Um, mm, okay. That's this one. Wow, that's a good one in Spanish. Okay. And what do I have here? Vajrasattva. Hmm. Oh, okay. There's the mantra in the NKT version. Oh, Vajrasattva Samaya Manupalaya Vajrasattva Teno Patita Drido Me Baba Suto Kayo Me Baba Supo Kayo Me Baba Anurakto Me Baba Sarva Siddhi Me Payatsa Sarva Karma Sut Same Chitam Sriyam Kuru Hum Ha 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 Ho Bhagavan Sarva Tathagata Vajramame Munta Vajra Baba Mahasamaya Satta Ahum Pe. Oh, that should be Vajri Baba. Vajri, Vajri, Benzri. Yeah, Vajri Baba. Vajrasattva. Yeah, that should be Vajrasattva. Vajrasattva. Okay, so maybe that. Wait a minute. Oh, okay. Oh, that's a PDF. I mean, a video. What's this? Wow, that's chicken. Oh, okay. See. Oh, yeah, there is a. Hmm. I can delete this one. Okay, I can delete this. Wow. I'll just delete that. Okay, so I got a lot of trimming to do. Let's go to Zoom and stop sharing. Oh, okay, I stopped sharing. Okay, thank you, folks. So yes, I looked at this one. I'd like to study this one. Mm, uh, uh, I'm going to go maybe do a little bit of breakfast and clean the kitchen and the bathroom because my sister has folks coming over, or one person to do some cooking. Bye. Thank you. Good luck. Should I say?